Welcome friends. Today we will be discussing about the methods of sampling. So different sampling methods are very important when we are planning to conduct any research or whatever research problems we are taking. It is very important to decide on what basis and with what hypothesis we are choosing the sample. So if you are choosing a wrong sample, your whole purpose of research will be failed. So in this chapter lecture, we will be seeing about the introduction to sampling methods. So first of all, we will see what is sampling, why sampling is needed, and what are the different types of sampling methods, how they may be conducted. So let us start with the introduction to sampling methods. So we all quite often use sampling in our day-to-day life. Whenever we go for purchasing anything, either vegetable or grains or whatever other commodities in the market, we usually examine a handful of. We just take a handful of that material in our hand from whole lot, and we will assess the quality of that material, and that process is called as sampling. So the sampling consists of taking a subset of a population for analysis to make an inference about the population from which the samples are taken. So what we are doing in the sampling, we are taking the subset of population. So first of all, we have to determine the population on which we have to take sample. So we will take subset of population, and that subset we are calling it as sample. Now there are few terms that is associated with sampling. So first of all is population. So what is population? All the elements that is individual items or objects whose characteristics we are going to study is called as population. So any population whose elements exist at a particular time is called as finite population. So many times you will encounter a situation where your population size will not be finite. So in that case, you will be telling that your population size is not finite, it is infinite. But a population is said to be infinite if it is not possible to count the units contained in that population. So many times you will be seeing the infinite population. The second one is sample. A portion of the sample selected for study is referred to as sample. So what is sample? It is a portion of population. A sample is smaller but representative. Sample should always be smaller. Why it should be smaller? Because we are taking sample in order to reduce our work. If you will take large sample as of that of a population, so it will always be better to study population itself. There is no need to take sample. So sample should always be small, but it should be representative. So this is the sampling procedure. Here you can see the population, and from that population, by applying certain techniques, we have chosen these units, and these units collectively is known as sample. So by certain procedure that we will be studying in the latter part of this lecture, with this certain procedure we will be selecting samples from the population. Now another term is census survey. So what is census survey? You might be aware about the census, population census, human population census. The census survey, it is a collection of information from the elements of population. So all the elements of the population. When we are collecting information from all the elements of a population, it is called as census survey. So a survey includes every element of the target population. Every element of the target population. Thus, in census survey, desired information on each and every element in the population is recorded. Whereas sample surveys, what we are doing, we are collecting information from the sample only. That is from the portion of population only. So this is the difference between sample survey and census survey. So the next question arises, why sampling is needed? So in the very first start of the lecture, I have told you why sampling is needed, but there are few points that you should know. The purpose of conducting a sample survey is to make decision about the population. So what we are doing, we are taking sample or portion of the population and we are studying that sample, and based on the study of that sample we are making a decision about the population. So that is why the sampling is very important, because based on the study of sample we are making decision about the population. If we are taking wrong sample, our interpretation about the population will be wrong, and in that case our decision about the population will be wrong. So the result obtained from a sample survey should closely match the result. This is very important. The result obtained from the sample survey should closely match the result expected to obtain from the census. So why we are taking sample? Because in assumption that the results obtained on the sample will be close enough from the results obtained by census survey, and that is why the decision based on sample survey will be applicable to the population. If it is not close, then we cannot apply the decision of sample, or we cannot interpret about the population based on the study on sample. The quality of sample statistics, that is accuracy, precision and representativeness. So the sample should be accurate, precise and representative. It is largely affected by method of sampling. So method of sampling is very important. Whenever you are taking sample based on our study, based on the population, based on the researcher and many other factors, we are deciding which method of sampling we have to apply. And this method of sampling we are adopting based on getting accurate result, precise result and representative sample. Then sampling can provide reliable information at far less cost than a census. We know in census each and every individual has to be approached for getting information. So that is very costly affair. If your population size is very large, then reaching to each and every individual for getting information, it will be very costly affair. So with the help of sample survey we will be reducing that cost and also the time. So data can be collected more quickly. So on sample we are collecting data more quickly, so estimate can be published in timely fashion. The estimate based on sample survey may be more accurate. Why it will be more accurate? Because in sample survey you have to take very few observations. So the researcher will be more alert. He will be concentrating more on those few samples, few observations only. But when you have to take a census survey, you will be bit relaxed, because or you will be lazy, or you will be thinking that okay, large number of observations I have to take, and so he will be researcher will be slightly relaxed. So in that case, chances of committing error is more. So that is why the sample survey may be more accurate. Now, the method of sampling. So there are many methods of sampling. The method of sampling has been broadly classified into two parts. The first one is probability sampling and second one is non-probability sampling. So in probability sampling, the first one is simple random sampling, systematic random sampling, stratified random sampling, cluster sampling, multi-stage sampling and multiphase sampling. And in non-probability sampling, it is convenience sampling, judgment or purposive sampling, and quota sampling. So these are the different sampling methods. Now we will be discussing each of the method of sampling in slight detail. So first one is probability sampling. So sampling process that utilize some form of random selection. So this probability sampling means there will be some form of random selection. In probability sampling, each unit is drawn with known probability. So whenever somebody is telling about the probability sampling, that means each of the unit will have some known probability, or it has non-zero chance of being selected in the sample. Each and every element of the population will have certain probability of being selected. That means it will have non-zero chance of getting selection. And this kind of sampling is known as probability sampling. So in probability sampling, there will be some probability, at least it will, any individual, any unit, each unit of the population will have certain kind of probability of getting selection. So in this probability sampling, we will be seeing different types of probability. Definition we have already seen. We will be seeing the example and what are the steps in doing this probability sampling that we will be seeing in the next few slides. So first one is the simple random sampling. Simple random sampling. It is applicable when population is small, homogeneous, and readily available. So these conditions you have to remember when you are applying the simple random sampling. Each element of the population has an equal probability of selection. So this is very important. Each element has an equal probability of selection. Equal probability. But for large population, this method is impractical. Why it is impractical? Because providing a unique identification to each element of large population is not feasible. So we will be seeing, if you will see the procedure, then it will be clear to you that in simple random sampling, we are providing unique identification number to each and every individual of that population, and then we are selecting few individuals randomly. So if all possible samples from the population are equally likely to be obtained, then we call it as a simple random sample. So this is very important point, that in simple random sampling procedure, each and every individual is having equally likely chance of getting selection. A simple random sample of n items in a sample which satisfies the following two conditions. So those two conditions you have to ascertain for simple random sampling. First, every member of the population has same chance of being included, that is equally likely. And second, the members of sample are chosen independent of each other. Independent of each other means, suppose this is the population. So suppose I am selecting this individual. If I am selecting this individual, the second time chances of getting selection of nearby individual is always same. It will be not like that if we are selecting individual A, chances of selecting individual B will be affected by the chances of selecting individual A. That means the chance of selecting each and every individual is independent of each other. So these are the two conditions for doing simple random sampling. Now the methods. So in method, there are two methods, lottery method and random number table method. So with this lottery method, just by simply performing lottery, you all know about the lottery, and we are picking the number based on the chance. And another method is random number table. So there is random number table. You will see random number table in any of the statistics book, or you can generate random number table in Excel sheet with the function of rand between is equal to rand between. You will be seeing, you will be knowing more about this in your practical classes. So what are the steps? First of all, you have to make the list of each and every individual of the population. Then you have to assign a sequential number. So you have to assign a sequential number to each and every individual of the population. So that is why in we have studied that if population size is large, so assigning number to each and every individual will be difficult. So in that case, simple random sampling will be difficult. So second step is to assign a sequential number. Third, use random number generator. So with the help of random number table or random number generation, you will be generating the few random numbers, and then we will choose the sample size. So the second one. Now the second one is the systematic random sampling or systematic random sampling or quasi-random sampling or interval sampling. So here what we are doing, we are arranging the target population according to some order. So what we are doing, we are arranging the population in some order, either in increasing order or decreasing order or whatever way, with the based on the color or based on the any number, and then select the animals at regular interval. Select the elements in the regular interval. So first of all, you have to order all the individual of that population, and then we have to select at regular interval. So for that there is certain procedure that we will be discussing in the next slide. It involves a random start. So first of all, we have to start randomly. So that is why it is a part of random sampling, systematic random sampling, and then proceed with the selection of every kth element. So first of all, you have to start randomly, and then you have to select every kth animal, kth element. So what is k? That you have to know. So in next slide we will see what is k. So we will be discussing the actual procedure of the systematic random sampling. First is prepare a list of elements from 1 to n. So you have prepared list from 1 to n, where n is equal to population size. Suppose you are having 100 elements in a population, so n is equal to capital N is equal to 100, and you have to arrange all the elements from 1 to n, that is 1 to 100. Now decide about the required sample size. How many samples you want? Suppose out of those 100 elements you have to select 10 element. So your small n, that is sample size, is equal to 10. Now you have to find the k. You have to find the k because you have to select every individual at kth interval. So k is equal to capital N by small n. That means population size divided by sample size. So this is the k. Now randomly select an individual between 1 to k. So now you are having k. Suppose you got k is equal to 5. Suppose you get k is equal to 5, or you see, suppose your capital N is 100, your small n is 10, so you will be getting k as 10. So you have to find a random number between a1 and k, and that will be the first unit to be selected. So 1 and k, suppose you selected fourth element, so the first unit is fourth. Now you have to select the subsequent unit after k interval. So k is 10. The first unit is 4, fourth item. Second unit will be 4 plus 10, 14th item. Third unit will be 14 plus 10, 24th item. Fifth unit will be 24 plus 10, 34th item. So like that you have to select the sample. You have to select 10 samples. So like that you have to go up to 10. So record observation on the first unit and every kth unit thereafter till the required sample size, that is n is small n is obtained. So hopefully this procedure is clear to you. We will just see one example, then it will be more clearer. Here you see what you have to do. You have to select a sample of 50 sheep. 50 sheep from a flock of 1500 sheep. So here capital N is 1500 and small n is 50. So you have to first find out the k. So k is equal to 1500 divided by 50, that is 30. So now you have obtained your k as 50. 30. Your k is 30. So from 1 to 30 you are having total 1500 sheep. From 1 to 30 you have to choose any one sheep randomly. Suppose I have chosen 10th sheep. So next sheep that I will be selecting, it will be 10 plus 30 is equal to 40th sheep. Another sheep that I will be selecting, 14th plus 30 is equal to 70th sheep. Okay. Another sheep that I will be selecting will be 70 plus 30 is equal to 100th sheep. So like that I will be selecting total 50 sheep. Here I have selected first sheep, then second, then third, then fourth, and like that I have to select total 50 sheep. So this is the procedure by which we are selecting the sample by using systematic random sampling method or interval method or quasi random sampling method. Now another small modification in this systematic random sampling is circular systematic sampling. So this is quite similar to the systematic random sampling. Here selection of elements is made in a circular fashion. What is circular fashion? Just we will see, it will be clear. From the population having element number from 1 to n, that is capital N, starting from the first unit, every kth unit of the population is included in circular manner in a set of samples. So like the earlier one that we have seen, we will be calculating the k as K is equal to capital N divided by small n. So in this sampling technique, the total number of possible samples are capital N. We will select a sample, random number, any random number, that is R, and subsequently we will be selecting the sample. Just see this example. Here, this is an example. Select a circular systematic sample of 5 out of 9 dairy farm. 5 out of 9 dairy farms. So you are having 9 dairy farm and you have to select a sample of 5. So what we will do, we will try to find out the k. So k is equal to 9 by 5. So it is coming around 2. So what we will do, we will choose any one from 1 to 2. So suppose I have started it from 1. So 1, then you have to 2. So 1, then 3, then 3 plus 2 5, then 5 plus 2 7, 7 plus 2 9. So your sample size is 5. So we have already selected 1, 3, 5, 7, 9, total 5 sample. Suppose I am starting from second element. So 2 plus k is equal to 2. So 2 plus 2 4, 6, 8 and 10. Because we don't have 10th, so we will go for 1 first. So this is the sample size. This is the sample that we have obtained. We have completed 5 dairy farm sample. Suppose I am starting with 3. So what we will do? We will be adding 2. So 3 plus 2 5 plus 7 plus 2 7 plus 2 9 and plus 2 it will be 11, but 10th and 11th is not there. So we will be starting, we will go for 1 and 2. So this is the way we are selecting in circular fashion. We will, where it is ending, the cycle will again start. Here you can see in this picture the total capital N, that is total population size is 20 and sample we have to take 4 and k is equal to 5. So what we are doing, we are randomly starting from second. So we have started from second and we have to select the 4 sample and k is 5. So 2 plus 5 is equal to 7. Then 7 plus 5 is equal to 12 and 12 plus 5 is equal to 17. So in this way we have selected the 4 sample. Suppose I am starting from 5th number. So 5th plus 5. 5 plus 5, 10th. So I will be selecting 10th. First 5, then 10. 10 plus 5, 15. 15 plus 5, 20. So like this, 1, 2, 3, 4. So any already small n is equal to 5. So I will be selecting one more. So 20 plus 5, 25, but 25 is not there, so I will be selecting the 5th one. Okay. No, only n is equal to 4, so only 4 sample. Okay. So like this we will be performing the circular systematic sampling. Now another method of sampling is stratified random sampling. So this is very common method of sampling which is being applied in our animal science most commonly. So here the term stratum, which means as layer. So what we are doing, we are dividing the whole population into different layers. So a stratified sample is made up of different layers of the population. Example, suppose animal of different age group, people of different socio-economic status, etc. So in this way we are layering the population. Suppose we are having a population of cow of different ages. So what we will do, we will make 3 layers. Cow with less than 1 year, cow between 1 to 2 year, cow between 2 to 4 year, and cow with age more than 4 years. So like this we have made the 5 layer of or 5 stratum of the cows. The whole population is divided into groups called strata, which are more or less homogeneous within themselves. So why we are making stratum? Because it will make the population homogeneous, because with respect to age the population was not homogeneous. So what we did, we tried to make homogeneous as far as possible. An individual group is called as a stratum or subpopulation, and the procedure of grouping is called as a stratification. So here you can see this is the population, and here based on color I have made it into different stratum 1, 2, 3 and 4, and from each stratum I have selected the sample randomly. So this is called as stratified random sampling. So the stratified random sampling consists of partitioning of heterogeneous population into fairly homogeneous group, that is a strata, then obtaining a random sample from each stratum independently, and then collecting data from each of these individuals. So this is about the stratified random sampling. Now another is the cluster sampling. So it is simpler to stratified random sampling, but there is slight difference. So what we are doing, sometimes the target population is scattered over a wide geographical area. So large geographical area you have to do sampling in that large geographical area. Suppose there is a very big forest, and in that you have to do the sampling of animals. So what we will do, consequently, if simple random sampling is selected, it may be costly to contact each member of the sample, because in simple random sampling you have to contact each and every member of the sample, member of the population. So here what we will do, we will divide the population into different geographical clusters. We will be dividing the population into different geographical cluster, and as a first step select the random sample of certain cluster from all the clusters. So we will be selecting the random sample of cluster. So out of those clusters we will be selecting the few clusters. Now the procedure for cluster sampling is accomplished by, first, what we will be doing here, you can see the whole population is divided into certain clusters, and then from those clusters we will be taking the few cluster as sample. Two clusters I have taken here. Obtain a simple random sample of clusters from all the possible clusters. So these clusters are being selected on the basis of simple random sampling. And now you can get the data from each of the sampling unit, that is from the randomly selected clusters. Now it is widely applicable in the geographical studies of different kinds where distribution is on very large area. It is particularly useful in the situation where the list of all the population unit is not available. When you don't have all the members of the population, information of all the members of the population, but it is known for a small portion of the population, then in that case we will be making the clusters and we will be randomly selecting the clusters. The fifth one is the multi-stage sampling. Multi-stage sampling. Here what we are doing, this is the combination of the earlier studied method. Here sampling is carried out in the stages using smaller and smaller sampling unit at each stage. So what we are doing, we randomly select the elements from each of the clusters. So what we are doing, first of all, we will be clustering the population into different clusters, and from those clusters we are taking elements. So here the sampling is done in two stages. First is the cluster formation. We are selecting the clusters and then we are selecting individuals from those clusters. So this is why it is called as multi-stage sampling. It is applicable when complete list of all the members of population does not exist and it is inappropriate. That means all the information is not available. All the information on all the individuals is not available. In that case, we are dividing the population into clusters. The same thing as we have already studied in the cluster sampling. Then another one is the multi-phase sampling. Multi-phase sampling, here the multi-phase sampling, here we are choosing certain items or information are drawn from whole the of unit. Suppose this is the population, and from population we have taken one sample, and from sample we have taken few observations, and then from sample we have chosen subsample, and again from subsample we are taking few observations. So these observations that we have taken, first from the sample and second from the subsample. So these samples we have taken in different phases. That is why it is called as multi-phase sampling. So what we are doing here, certain items or information are drawn from the whole unit of a sample, and certain other items are taken from the subsample. That is, part of the information is collected from whole sample and part from the subsample. So that is why it is called as multi-phase sampling. So this was all about the probability sampling. So in this probability sampling we have studied total 5 different kind of sampling methods, and one was the associated sampling method. So the next one is non-probability sampling method. So non-probability sampling method depends on our personal judgment. It depends on the personal judgment of the researcher. We will see how it depends on personal judgment. In this method of sampling, the probabilities cannot be assigned. So what we had seen in probability sampling, that there was certain kind of probability associated with the observations or associated with the samples. But here in non-probability sampling, probability cannot be assigned to the unit. Any sampling method is non-probability sampling method where some element of the population has either no chance of selection or whose probability of selection cannot be accurately determined. That means selection of sample or selection of elements from population is not based on the probability. There are few of elements for which probability of selection into sample we cannot ascertain. So that kind of sampling is called as non-probability sampling. So first in that non-probability sampling is convenience sampling. Convenience sampling. So convenience, as the name reflects, it is based on the convenience of the researcher. So this type of non-probability sampling, which involves the sample being drawn from the part of the population which is close to the hand, that is, which is close to the researcher. Here you can see this is researcher, and he has to take sample. So this convenience sample, what he will do, he will select the nearby individuals or nearby elements, and these nearby elements will be taken as the sample. So this is called as convenience sampling. Convenience sampling is very useful, particularly when we are dealing with the geographical area which is inaccessible, which is not readily accessible by the sampler. So in that case, convenience sampling will be the handy. Second one is the judgmental or purposive sampling. So here the units are considered based on the judgment of the researcher. This sampling is made on the basis of knowledge of the population and the purpose of study. So what we are doing here, researcher is the person who, based on his experience or his knowledge about the population, he will decide the elements that he has to take into the sample. So based on the judgment of the researcher, he will be taking the sample. That is why it is called as judgment sampling or purposive sampling. Purposively, researcher will take few samples from the population. The main goal is to focus on particular characteristics. That means researcher will decide which characteristic for which characteristics he want to conduct his study, and based on that characteristic, based on that purpose, he will be taking the sample. Example, as an animal breeder, suppose I am an animal breeder, my intention will be always to select animals who are performing best with respect to milk yield or body weight or any economic traits. While on the other hand, I will not be interested in the individuals who are poor in the performance, so I will be removing those individuals. So this kind of selection, if a breeder is doing selection, that will be a non-probability sampling, and that will be a purposive sampling or judgmental sampling. Now what are the merits? So merit of this judgmental sampling, it saves time and money. Then it is only practical method of choice available for studying the infinite population when population size is infinite. So what we will do, we will do the judgmental sampling, and it enables us to collect a broad range of data. With this we will be collecting the broad range of data. Then what are the demerits? It is not suitable if information required on each and every individual. If you want each and every individual observation, then we cannot do the non-probability sampling. Also, it is not advocated in very small population. Why? In a small population, we cannot do this non-probability sampling or judgmental sampling because the sample will not be the representative one. The next one is the quota sampling. So quota sampling, here researcher creates a sample involving individuals that represent a population. So researcher, based on his assumption or based on his criteria, he will be selecting the sample. Researcher choose these individuals according to specific traits or qualities. Based on certain traits or qualities, he will be interested in choosing the sample. Suppose here the researcher is interested in selecting or choosing sample of male having age more than 50 years. So based on this criteria or this specific trait, he has selected this sample. So this is called as quota sampling because the male individual having age more than 50 years is having quota of selection. So this is called as quota sampling. So with this, here I am ending the sampling methods, lecture on sampling methods. Hopefully this sampling method is well understood by you. This both the two sampling method, that is a probability sampling method and non-probability sampling method. So in next class we will be studying something else. Thank you.